All right, so this is lesson 7.7, the natural log base of e. So common logs have an implied base of e. So when we see log 100, log base of 10, we're going to get to e, we assume that that's at base of 10, which we know as the common log. So if your problem is written as log base 10 of x, then you can simply write it as log of x. So that common base of 10 we've already talked about. So reviewing that, we have 10 to the what power equals 1,000. Well, it is 10 cubed. Here, 10 to the what power gives you 10, 1. 10 to the what power gives you 1, 0. So what we're going to talk about in this section is what's called the natural log. So that's kind of another common log where the base will not be written, but it's implied. So if that base isn't written for both the common log and the natural log, we will know which type of log we have. So that one, we should have some sort of blank here. Where did that go? Up at the top here before all this. But that natural log is base E. So that's that blank up above that in your notes. So if you see ln, which is natural log of 5, it's got that implied base E, and it could be written as ln base of E5, or even just log base of E5. So these all mean the same thing. They're all bases of E. So it could be nothing there, which implies that there is that E there, or written with the E, or a log base E of x. They're all the same thing. But the most common way you're going to see it, unfortunately, is where it's not written. So that ln button on your calculator stands for the natural log, which is a base of e. Now, going back to what e is a famous irrational number, and it's one of the most important numbers in mathematics. The first few digits are 2.71828, and it goes on and on and on, similar to pi, but Euler discovered this number, and it's seen a lot in nature and stuff like that. So that's where this number, this random weird number, came about, kind of like pi. So pi and e are both irrational numbers that are very important to mathematics. So let's go ahead and work with our natural log. So we're going to write this in exponential form. So remember, if our base is not written, so this equals our exponent still a log. So we have a base of e. We don't know our exponent, but we know that it's going to get us x. So same way that we did logs, and here's 2 examples there for you. So let's do some down here. So base of e, so we're going to have either log e, there it is, with our 4 equals our exponent x, or just ln, which is the same thing as the natural log of e, 4 equals x. One more, and then I'll have you try the next one. So log base e of x equals our exponent 5. Or, again, log base e is just ln of x equals 5. So try that next one on your own. Rewrite it with that base that we know is e, and check when you're ready. All right, so it's e as your base to the x power equals 6. The next one, this is a base of e to the 0.7741 power equals x. All right, so we've got some properties here, and we have seen these properties before. So this is going to apply to not only the properties of logarithms that we've already covered, but also to the natural logarithms. So expanding, remember multiplication changes to addition. Condensing, getting smaller, addition becomes multiplication. Going from the quotient, division, becomes subtraction. So subtraction can become division, vice versa. The power property, so that's just rewriting where we put our exponent in front. Okay, so that works as well. And then the inverse. So when we've got the same, when it's ln to the base of e, and then we already have a base of e, it's going to cancel that out, and we're going to be left with our exponent. Same thing when it's e with an ln, that's going to cancel, that's inverses, and we're left with our answer there. So other properties that are important are going to be natural log with a 1 here equaling 0. So that's e to the 0 power equals 1. Still anything to the 0 equals 1. E equaling 1. So e to the first, anything to the first is itself, so it's e. And then here, e to the m is going to be equal to e to the m. Okay, so that's just basically what that's saying. All right, so let's go ahead and practice down here. So for our first one, we're going to put our exponent here. We're just going to condense it because subtraction means we're going to make it smaller. We wanted to use division, but we've got to get any front things changed to exponents first. All right, so now we can change that subtraction to division, keeping just a base natural log there, and we have 10 to the third over 8. Done. All right, so addition is going to become multiplication, but we want to move those to become exponents and coefficients first. So ln natural log of 40 and natural log of a to the second plus natural log of x. So we're going to just have 1. And then this is all going to become multiplication here, 40, and then the a squared, and then the x. So try that last one on your own, check when you're ready. All right, so first step is to move those coefficients to become exponents, change subtraction to division, and then we can do 4 squared and make it 16, and we're done. So this goes on the top, and then the 16 on the bottom. All right, so let's take a look at practicing with a base of e. So what do we do here? Well, let's go ahead and rewrite it with our base, and then we're going to solve for our x here. So this is really ln natural log of e to the 8. We're just going to rewrite it in exponential form, or logarithmic form in this case, kind of, equals 3x. So we can go ahead and divide by 3 here, divide by 3 here, and then we can use our calculator for this one if we get x by itself. So typing in natural log of 8 divided by 3, because we don't really need that base of e, that's that one that we know that it is. So just typing that into our calculator and get 0.693. All right, so let's try one more. So ln of e, then we know we're going to have our 5, and then it equals the exponent, and our exponent in this case is negative 4x. So to solve, divide by negative 4. So in our calculator, we're going to type in the natural log of 5 and divide it by negative 4 to get our answer of negative 0.402. All right, so go ahead and try these last 2 on your own. This one has a few more steps in there with solving, because you got to add first and then divide, but I want you to try that one and check when you're ready for both. All right, so let's go ahead and start with this one. So natural log of e, 6 equals x plus 5. Then we're going to solve for x, so subtract 5. So in your calculator, do the natural log of 6 and subtract 5 to get your answer. Over here, natural log of e, so keeping it base e, and then of 24 equals your exponent 5x minus 3. So 2 steps here, add 3, and then divide by 5. So make sure to do the natural log of 24 first, hit enter, then you can add 3, enter, then divide by 5, enter, to get 1.236. So rewriting it and then solving for x. All right, let's take a look here where we're going to condense it. And what that gets us is natural log of 4x, because it's multiplication when it's addition. If you need your little base of e there, you can add that. And then we're going to rewrite it. So base of e to the 24th power equals 4x. And then what we can do is divide by 4 to get x. So in your calculator, we'll take e to the 24th. There is an e button. e is not a variable, so keep that in mind. There is a button on your calculator. It's, if you can't find it, look for it, or you can do a Google search and probably do that on Google, and it will do it for you. But we're going to go ahead and just rewrite it and leave it in that form, actually, so you don't have to find that button. There we go. We're going to leave our answer as that. All right, so let's go ahead and rewrite this one. Base of e to the 8th power equals 6x, and then solve by dividing by 6. So x equals e to the 8th over 6. All right, on the next one, we can cancel our logs since they match up on both sides. And then we can solve. So I want you to go ahead and finish solving that one and check when you're ready. All right, so add 2x, add 4, divide by 6, and we get 7, 6. So the next one, we can go ahead and condense. Since it's addition, we want to change that to multiplication. So it's x plus 9 times 9, which means we're going to distribute here. So then it is the natural log of 9x plus 81 equaling 3. So got this base of e here, base of e to the 3rd equaling the 9x plus 81. And then we'll go ahead and solve. So we'll subtract 81 and then we'll divide. Subtract 81. So e to the 3rd minus 81 equals 9x. And then last step, divide by 9. So our final answer here is going to be x equals, and then it's our e to the 3rd minus the 81 over 9. Okay. All right, so let's take a look. Oops, I covered it up. There we go. All right, so subtraction here is going to be division. So it's the natural log of x over 7 equals 4. Add in your base of e if you need to. Rewrite it, and then solve. So multiply by 7. So x is going to equal 7 times e to the 4th. Try that last one on your own. It is going to be division. And then, so condense it. Then you'll cancel the logs on both sides, and then you'll finish solving. All right, so condensing it, 3 divided by x. Then the natural logs cancel there. And then we have 3 over x equals 15. And then you could just put this over 1 and use cross multiplication to get your 1/5 for your answer.